Hey guys, I want to do a video on unit dimensional analysis. It's a procedure that chemists use to convert between one unit to another. And it's based on the relationships between different units that express the same physical quantity. What I mean by two different units that express the same physical quantity, I'll use length as an example. Centimeters to inches. They both measure length, but they're different measuring set. So they have a relationship, but what is that relationship? Well, I looked it up, 2.54 centimeters are every inch. So now we know the relationship. And we can also display this relationship in a thing called a conversion factor, which we'll need to calculate more complex questions converting different units. So what we'll look at is simple ratios of our relationship that we can use in a calculation. 2.54 centimeters, I'll write it over 1 inch, and vice versa. It does not matter. There's a reason it doesn't matter, because technically both these are equal to 1. Now you're looking at me, hey guy, 2.54 centimeters divided by 1 is obviously 2.54 centimeters. No, 2.54 centimeters over inch, which is 2.54 centimeters, it's 1. All conversion factors are equal to 1, which lets us use them in calculations without compromising the integrity of our calculations. So if you go to the next board, I'll show you how to apply dimensional analysis. To apply dimensional analysis, we multiply a known quantity by a conversion factor, which technically equal 1, but not literally, to obtain values with desired units. We use the relationship given quantity multiplied by a conversion factor equals the desired quantity. What that looks like in unit form is a given unit multiplied by a desired unit over a given unit equals desired unit, because these two cancel, leaving us with a desired unit. So in the next part, I'm going to do an example problem. It's pretty simple, but we'll get to some more complex ones in the next video. How long is 23 feet in centimeters? Well, follow me, let's do this. Well, we're going to begin with an extensive property. And what an extensive property is a property in which the amount of substance matters. For instance, mass and volume. The amount of mass and volume matters compared to something like density. No matter how much water you have, if it's the same temperature and pressure, it's going to be the same density. So what we're going to do is do this calculation. Begin with extensive property. Well, we only have one property in the calculation. It was 23 feet. So we start with 23 feet. We then choose appropriate conversion factors. For every foot, 1 feet, there's 12 inches. We can't go directly from feet to centimeters because we don't know the conversion factor. I didn't look it up. I want to show you how we can do it in steps. So for every foot, there's 12 inches. And from inches, we can get to centimeters. So let's begin. So we can cancel out feet to inches. For every foot, there's 12 inches. Alright, next we're going to do from inches to centimeters. And it's the same. And I'm picking the conversion factors that allow me to cancel units I don't want. So I could write it the opposite way if I wanted. But it wouldn't make any sense. So for every 1 inch, there's 2.54 centimeters. So we multiply it out. That's all you do in unit dimensional analysis. You just multiply it out. It's just like stoichiometry, you'll see. Cancel, 23 feet, inches, leaving you with an answer in centimeters. I've already done it. Not in my head, that'd be pretty cool, but did it before the video. Times 10 to the 2 centimeters. In the next video, we're going to do some more complex examples. Thank you.